Now let's learn about the core features and components of React Native. So the very first one we are already talking about and talked about too much is the cross-platform development. So React Native obviously is a cross-platform mobile application development framework which allows us to write the code only once and deploy it to multiple platforms, and obviously reduce our development time, reduce our development effort. Then this cross-platform capability is achieved using the React library, or we can say this capability is achieved using uh, the code that is only JavaScript code, which can be shared on iOS and Android, because this code gets compiled into for iOS it will be compiled to Swift or Objective-C, and then for Android it will be compiled to Java or Kotlin, and like that. So it saves us time, effort, and yes, compared to developing for separate code bases, it is much more efficient. If we develop separately for iOS, we have to write Swift code and use different tools for iOS development, and then if we develop for Android, we have to write in Java or Kotlin. Then we have to use different tools, different testing tools, different debugging tools, and everything different for Android and iOS. But with React Native, we can use just single development tool, single testing tool, debugging tool, and yeah, like that. We obviously need some different development kits. For example, for iOS development, we need Xcode tool, and for Android development, we need Android Studio. But we can even remove those tools if we are developing some very basic application. There is something known as Expo available to us. Now this Expo doesn't require anything on the system. It just requires us to write the JavaScript code, and using the cloud, it will compile everything and will build an application, Android and iOS, for us, and will give it to us. The next feature is JavaScript code base. So React Native uses this modified version of React. So React is obviously a JS library. This was initially introduced to develop the web applications, but later it was then optimized for mobile development environment also. So the React Native is using this optimized version of React, that is a JS library. The optimized version is optimized for mobile development environments. The third feature is the native components. What does this native component means? React Native provide a full set of pre-built components that are rendered using the native APIs. So for example, if we are developing for iOS, and the other thing we are developing for Android, so there are some core components available to us from React Native. So these are view, text, and text input, and then scroll view. If we compare these components with HTML, view is just a division, text is a paragraph tag, text input is the input tag, and scroll view is just a scrollable division. So these are some core components available to us from React Native. Now these core components, when we load them into the screen, these core components go to the native side, and check what corresponding component is available for them to be loaded. So on the iOS side, suppose there is a component iOS view. There is not such a component available in iOS. I'm just taking an example. There must be, there is something like UI view controller or stuff like that in iOS. I'm just saying iOS view so that it is easy to understand. So suppose there is this iOS view and then iOS text, then also iOS text input, then there is iOS scroll view. So when this view is loaded, and if we are developing for iOS, it will go to the native side and check what corresponding component it is available for that to get loaded. So it will leverage this iOS view component and will be replaced by this iOS view component, and this view is going to be loaded on the screen. Similarly, text is going to go to the native side and check what it is going to check what native component is, what corresponding native component is available for the text to be used. So it is going to render this iOS text component, and this iOS text component is going to replace the text component that we have used on React Native side. Similarly with text input and scroll view. And the same case is going to be happened with Android, that there is some Android view, there is some Android text and text input and scroll view. So these views, text and text inputs are going to go to this Android view, Android text, text input, and yes, they are going to leverage these native components and going to be replaced by these native components. So that's how we feel these React Native applications as native applications only, because they are not using their own components, any other components. They are using the platform specific components only. Whatever the native components are available, they are using those components only. So they feel like native applications. The last and the very important feature of React Native is the bridge communication. We already saw some overview about the bridge communication, that whenever we are developing using the JavaScript, or we should say when we are developing using React Native, so there is the JavaScript side of the project and there is the native side of the project. So JS and iOS or Android. Now, all of this is going to be packaged, compiled and bundled into a single file. So for Android, it is going to be bundled into the APK file, and for iOS, it is going to be bundled into IPA file. Now, when these files are going to be loaded on the platforms, suppose this IPA file is going to be loaded on iOS device. Now this iOS device is going to run the JavaScript side on the JS engine and going to run the native side on the native platform. Whatever project is available into the native side, so the native platform will be able to handle that, and the JavaScript side will be handled by the JavaScript engine that is there on the platform. Now, in this single application, both of these needs to talk to each other, needs to send some data, needs to send some logic, some responses, and stuff like that. So here comes the role of the bridge, that whatever things are happening on the JS side needs to be coded or serialized and needs to go to the native platform side, and this native platform has to deserialize it, check what is being performed on the JS side, and then needs to serialize the response and send it back to the JavaScript side. Now this JavaScript side will need to decode this and understand what change has to be made on the UI side. So here comes the role of the bridge. Now this bridge was having some complications. Let's take an example. Suppose there is a text input and we are entering card details. So we are entering a 16-digit card number and we want a space after every fourth letter. So after entering each letter, we are going to check if the space is needed after that or not. So let's say the user inputs 1 here. After entering 1, this change gets serialized and goes to native side. This native side deserializes it and checks what is the change being made and does it require any native side change to be implemented after this. So it checks it that it is just the first digit, so it doesn't require any space after that. So it sends back the response that no space is required, so we can add the other digit. Then we add 2. It again goes to the native side checks it and serializes it, goes back to it, deserializes the code. Then we enter 3, similarly we enter 4. Now as soon as we enter 5 here and this change gets serialized, this change goes to the native side. This native side judges what change has happened. Now after judging that the 5th digit is being entered, this native side wants a space to be implemented before this 5th digit. So it sends the response that a space has to be added. So first it was being printed like this, but after the response got received on the JS side, a space was added here and the 5th digit got shifted to the next column. So this is what were the complications with the bridge architecture, that there were some delays because there was too many serialization and deserialization happening from JS side to native side and then native side to JS side, and there was lack of smoothness, lack of optimization, and yes. So to solve all of these, React Native has introduced a new architecture, that is the JSI architecture. We'll see some overview about it. It is something like, suppose this is a native site and this is the JS side, JavaScript side. So now there is some object reference that is having the references to all the native functions. These are the native APIs. It is having all the references to these APIs and functions, and this object is being exposed to the JS side. So when this JS side needs anything from the native side, it can directly access because it has access to this this reference object. So all of this is being exposed using C++. Now using this object, this JavaScript side is now accessing everything, and there is not much serialization and deserialization is needed, which was being needed on the bridge architecture. So this is about the new JSI, JavaScript Interface Architecture, using Fabric. Okay, now let's move to the next slide. Let's see what are some benefits and advantages of React Native cross-platform mobile app development.